Welcome to Chapter 5, Solving Equations. This is the first chapter that we'll be doing in business math. Some of this should hopefully be review from if you've taken any algebra classes in the past. So let's get started. So this is just kind of a fun math problem to try to see if you remember order of operations. So just as a reminder, you have to do division first. So you'd actually do 3 times 3 over 1, which is 9. So you have 9 minus 9 plus 1. So that's 0 plus 1, which is 1. All right. So some basic equations, how to solve these. So basically when you solve equations, you work backwards to isolate the variable, to get that variable alone. So for example, if it's next to each other, that means it's being multiplied, and in order to undo multiplication, we do division. So I'm going to divide both sides by 8 because I want to get x alone, so I need to get rid of the 8. And what I do to one side, I have to do to the other. So those end up canceling out, and I'm left with x equals 24 divided by 8, which is 3. Over here, now a is being divided by 3, and so if I want a alone, I need to undo that. The opposite of dividing is multiplying, so I'm going to multiply by 3, and what I do to one side, I have to do to the other. So those cancel. I'm left with a equals 6 times 3, which is 18. All right, and then down here, to get x alone, this is a positive 4, so I'm going to subtract it to the other side. So that gives me x equals 6. Right here, this is actually a two-step equation. And to decide what I get rid of first, you're going to use PEMDAS backwards. If you remember, order of operations is PEMDAS, so please excuse my dear Aunt Sally. So if you think of PEMDAS, so this stands for the order in which you perform operations, and then it's backwards if you're solving an equation, if you're trying to work backwards to get x alone or whatever the variable is. P stands for parentheses, E for exponents, M and D are multiplication and division, and multiplication is not necessarily before division. This is just from left to right. And then addition and subtraction are in the same family, so you do that last, but you don't necessarily do addition before subtraction. That, again, is also from left to right. So addition and subtraction are in basically the same category as our multiplication and division. So right here, if I want to get x alone, I need to get rid of the 7, and I need to get rid of the 4. So I'm going to get rid of addition and subtraction first. So I'm going to subtract the 4 from both sides. That leaves me with 7x equals 35, sorry. And then to get x alone, since that's being multiplied, you're going to divide by 7 on both sides. So you're left with x equals 5. And you can always plug it back in to check it. 7 times 5 is 35 plus 4, oops, is 39. It's doing this. All right. So another multi-step equation here. If you have multiple a's on the same side, or x's, whatever the variable is, you're going to actually combine those first. So I have 7a plus 4a gives me 11a. So I have 11a minus 5 equals 39. And it's kind of, you don't have to do anything with the a's. It's kind of like saying 7 apples plus 4 apples. Now I have 11 apples, right? So now to solve for a, so first get them together. Now I can do my solving the same way I did the last problems. So to get a alone, I need to get rid of 11, and I need to get rid of negative 5, which means I need to move them to the other side. So to decide what I do first, I'm going to do PEMDAS backwards, which means I need to get rid of any addition subtraction first. So this is subtraction, so I'm going to add it to both sides. That cancels, so I'm left with 11a equals 44. And then here, since these are being multiplied, I need to get rid of it through division. So if I divide those, I get a equals 4. Right here, you have a couple of options. So if you do PEMDAS backwards, you notice you have a multiplication, because that's next to it, and you have a parentheses. So I'm going to get, if I'm going backwards, I'm going to get rid of multiplication and then get rid of the parentheses. So I can actually divide by 6 to start. That goes away, and I'm left with a plus 2 equals 4. And then to get a alone, I can subtract 2, which gives me a equals 2. Sorry about my handwriting, by the way. This pen is hard to write with. The other option, what you could have done at the beginning, is you could have actually distributed the 6 to start, giving you 6a plus 12 equals 24, and then do your 2 steps. So subtract the 12 to give you 6a equals 12, and divide by 6 to give you a equals 2. Either way, same answer. Okay, over here you have subtraction you're going to get rid of first, and then division, right? Subtraction and then division. So first I'm going to add the 5 to do the opposite, and I get a over 2 equals 6. Then I'm going to multiply both sides by 2. That gives me a equals 12. Okay. If you want to try solving that later, you can. That's not the right answer, actually. So let's look at some word problems here. It says, Wilson works 3 times as many hours as Nicholas in a month. If the total number of hours both work is 200, how many hours does, I should say, Wilson work? Okay, so you need a variable here. So let's say everything kind of depends on how many hours Nicholas works. So let's let x equal hours Nicholas works. So the total number of hours both work is 200. So a lot of times when you see the word total, that's going to mean some equation equals that. So you're going to have some equation equals 200. Now the 200 is made up of how much Wilson works plus how much Nicholas works, right? To give us a total of 200 hours. Well, we don't know how much either of them works. We said that Nicholas works X hours. So Nicholas, he works X hours. Well, Wilson works 3 times as many hours as Nicholas. So he's whatever X was times 3. So 3X. And now I can solve this. So you can combine those together. 3x plus x gives you 4x, because that's like having a 1x. 3x plus 1x is 4x's. And that equals 200. Now to solve, just divide by 4 on both sides. And x equals 50. So if the question was how many hours does Nicholas work, that would be your answer, because remember x is the hours that Nicholas works. But we wanted to know how many hours Wilson works, and he works 3 times as many hours as that. So he is 50 times 3, which is 150. So he works 150 hours. Okay, next one. Amber spent a total of $950 this semester on 600 items from the vending machine. In the vending machine, Cheez-Its cost $1.75 each. Ridiculous if you ask me. And Dr. Pepper cost $1.50 each. How many of each item did the Amber buy? Not just Amber, the Amber. All right, so this one would actually require 2 equations. And I know that because there are 2 totals. There's a total of $950, and then there's a total of 600 items. All right, so the $950 is made up of how much I spent total, right? So how much I spent on Cheez-Its plus how much I spent on Dr. Peppers, which are the best soda in my opinion. And then the 600 is made up of how many items bought. So how many Cheez-Its plus how many Dr. Pepper. So 600 items. So let's think of what our variables should be. So in order to figure out your variables, often you're looking for the unknown. So you're looking for what you don't know. And if you look at the last question, a lot of times that will tell you what you don't know. It says, how many of each item did the Amber buy? So I need to know the number of Cheez-Its. And I also need to know the number of Dr. Peppers. Those are the two things I don't know. So I can just call them X and Y. If you want to use C and D for Cheez-Its and Dr. Peppers, that's fine too. I like using X and Y in case I graph it or put it into a calculator. So the 600 items is made up of the number of Cheez-Its, which is X, plus the number of Dr. Pepper, which is Y. Now the 950, notice that was money. So I need so the entire equation then is going to be about money. So you're going to look for all the information about money, basically. So remember, $950 is made up of how much I spent on Cheez-Its and Amber spent on Cheez-Its and how much she spent on Dr. Pepper. So she spent $1.75 on Cheez-Its, but it was $1.75 times however many Cheez-Its she bought, right? If she bought 2 Cheez-Its, it's going to be $1.75 2 times. If she bought 5 Cheez-Its, it's going to be $1.75 times 5. So this is going to get multiplied by the number of Cheez-Its, which we don't know, but we let X represent that. So it's $1.75 times X. And then how much that was spent on Dr. Pepper is $1.50 times however many Dr. Peppers, which is Y. Now there are a couple ways to solve this. If you remember from algebra, you can do substitution where you get one variable alone and plug it in to the other equation. There's elimination where you try to get these to be the same number and multiply an entire equation by a number and then cancel them out. But the way that I prefer and the way I'm going to show you is graphically. So you can solve this just by graphing the two equations, so that equation and that equation, and seeing where they cross. Because wherever they intersect, that's going to be some xy value that works for both equations. And when you solve this, that's what you're looking for. You're looking for the one xy value, that one xy point that will work in each equation. That's the solution. So I'm going to use Desmos to do this. Some of you may be familiar with Desmos, others maybe not. But pull that up here. So if you graph this, I graph 1.75x plus 1.5y equals is that 950? And then the other equation was x plus y equals 600. Now you're going to have to zoom out. You can actually change the window right here. So let's say I want y to go to maybe 600. Maybe we need to go higher. Okay. And then maybe x needs to go a little farther. Okay, so now if you look at your graph, oh, this thing's being fickle. You'll notice they cross about right there. So if you click on it, it'll tell you where that point is, and it's at 200, 400. So that means the solution to this is 200, 400, where 200 was your X and 400 was your Y. So that means I have 200 Cheez-Its and 400 Dr. Pepper in order to make these equations both work. So I would recommend solving that by graphing, but you are welcome to solve it in any way that you can see fit. Okay, proportional. To be proportional, that means that if these two fractions were reduced to their lowest terms, they'd be the exact same fraction. And the way you can figure that out, there are a couple different ways. One is to see if I, basically if I could multiply this fraction by the same thing on top and bottom, and I get this fraction, it's proportional. So if you notice on top, if I multiply that by 3, I get 9. If I do the same to the bottom, I get 30. That didn't work. So that is not proportional. The other way you could do this is to do cross products, so cross multiply. So you do 3 times 20, and you see if that's equal to 9 times 10. 3 times 20 is 60, 9 times 10 is 90. They are not equals, they are not proportional. You can do the same thing here on number 2. So to get 8, I had to multiply it by 2. So if I do the same thing to the bottom, 15 times 2 is indeed 30. So this one is yes. If you would have rather done the other method, the cross products, I have 4 times 30, and I need to check and see if that is equal to 8 times 15. 4 times 30 is 120. 8 times 15 is also 120. So yes, they are proportional. So to solve proportions, you actually can use cross products. So I can do 7 times 9 and set that equal to 18 times n. And then you just solve for n. 7 times 9 is 63, and that equals 18n. And then just divide by 18 on both sides. And if you divide 63 by 18, you get 3.5. Now, you may have seen another way to do this as well. If you notice, I have to multiply or divide the numerator and denominator by the same thing to get an equivalent fraction. So if you notice, 18 divided by 2 would have given you 9. So if I do 7 divided by 2, that's going to give me n. 7 divided by 2 is indeed 3.5. So there are a couple ways you could do this. So if you did it that way here, you know, to get from 7 to 14, I multiplied by 2. So if I multiply 9 by 2, I get 18. So n should be 18. But if you wanted to do cross products, you could do 14 times 9 equals 7 times n. 14 times 9 gives us 126. And then to solve for n, just divide by 7. And n equals 18. Ta-da! Okay, some word problems you might see with proportions, sorry. So let's say your car gets 23 miles to the gallon. So that means 23 miles per, which you can do division, per 1 gallon. And I want to know how far can you go on 16 gallons. So you can set up a proportion here, which means a fraction equals a fraction. But just make sure you're consistent. So if you have miles on top there, you're gonna put miles on top here. If you have gallons on bottom, you put gallons on bottom. So for 16 gallons, I'm gonna put the 16 down here with the gallons, and I'm trying to figure out how many miles I can go. So that's my X. And then you can just do cross products. So I have 23, times 16 equals X times 1. So that's just X. 23 times 16 is, I don't know that off the top of my head, 368. So you can go 368 miles. Okay. So this one, the largest pumpkin ever recorded, that's it, isn't that huge? was 2,323 pounds. If a 4-pound pumpkin yields about 1.5 cups of pumpkin puree, how many cups of pumpkin puree would the largest pumpkin make? So let's set up a fraction here. We know that 4 pounds yields 1.5 cups. So I have 4 pounds yields 1.5 cups. So I can set that up as a fraction. And I'm going to set that equal to another fraction, and remember I want to be consistent, so if I have pounds on top there, I'm going to put it on top here. So the largest pumpkin was 2,323 pounds, so that's going to go on top, and I want to know how many cups, so that's my X. And then I just do cross products. 4X equals 2,323 times 1.5. Well, 2,323 times 1.5 is 3,484.5. And then to solve for X, you just divide by 4. Oops. And that gives you 871.13 if you round. And the units were cups. That's a lot of pumpkin pie. Okay, here's another one. €1 is equivalent to 1.08286 US dollars. So we lose money if we go over to Europe, right? So €1 is equivalent to, so things that are equivalent we can put into fractions. It's equivalent to 1.08286 US dollars. Now this is true, I had 48 euros left over, and I wanted to know how much money I could get in US dollars if I turn that into the bank. So 48 euros, and I want to know how many, so X US dollars. And then again, just cross products. 1 times X equals 48 times 1.08286. 1X is just X. 48 times 1.08286 is 51, and since it's money, I'm going to round to 2 decimal places, $0.98. So I had about $52 left. Okay, there's some more that are very similar. Solving for a variable. So that just means get the variable by itself. So if I want to solve for n, that means n I want to be alone on one side of the equal sign. Now this one's a little tricky because n is in the denominator. So very first thing you need to do is actually get that out of the denominator because we can't work with it in the denominator. So if it's in the denominator, that's because it was being divided. So to get it out, I'm going to do the opposite, which is to multiply. So I can multiply both sides by n. That gives me n times p equals t. And then to solve for n, I'm just going to get n alone now. So since it was being multiplied by p, I'm going to divide by p on both sides. Now you can't actually, those canceled. You can't actually divide by p, so it just stays n equals t divided by p. And this is considered solving for n because n is alone. Okay, and that's a formula that you'll use later down the road when we do installment payments. BMI formula, that's calculating your body mass index for fitness reasons. So this is using your weight and your height. So if I'm solving for W, if I'm solving for my weight, that means get W alone. So that means I have to get rid of the 703, I have to get rid of the h squared. First thing you're going to do is get rid of what's in the denominator, so I'll do that by multiplying. That's going to give me h squared times b equals 703 W. And then to get W alone, I'll just divide by 703. And that gives me W equals h squared b divided by 703. Okay. And that concludes chapter 5. If you have any questions, please feel free to email me.